Good morning. It's September 27th, and this is your daily brief in science. Here's everything you need to know. Astronomers have made a significant discovery with the identification of an Earth-like planet named KMT 2020 BLG 0414, located approximately 4,000 light-years from our planet. This finding provides new insights into what the future of Earth may look like after our Sun evolves into a white dwarf. The planetary system features a white dwarf star, which has about half the mass of the Sun, and an Earth-sized planet that orbits at a distance twice that of Earth's current orbit. The white dwarf is the remnant of a star that went through a destructive red giant phase, leading to extreme conditions on the newly discovered planet. Consequently, KMT 2020 BLG 0414 has likely cooled from a molten state to its current frozen state. This discovery raises questions about the fate of humanity during the Sun's future red giant phase, particularly regarding the survival of life under such harsh conditions. Models indicate that while Earth might escape being engulfed by the Sun, it may not remain habitable as it could be pushed out of the habitable zone. As the Sun expands, the habitable zone may shift outward, potentially paving the way for humans to migrate to the moons of Jupiter and Saturn, which could become suitable for life. The discovery was made possible through a microlensing event observed in 2020, where the gravitational field of the star system magnified the light of a distant star by over 1,000 times. The findings, published in the journal Nature Astronomy, enhance our understanding of star evolution and its impact on surrounding planets. Lead author Keming Zhang from the University of California noted that Earth may only remain habitable for another billion years due to the impending greenhouse effect. This research not only sheds light on Earth's potential fate, but also illustrates the diverse planetary configurations that can exist around stellar remnants. A new study is shedding light on the intriguing possibility of detecting primordial black holes, or PBHs, through their gravitational influences on objects within our solar system. Researchers have found that a PBH passing close to Mars could cause a measurable deviation in its orbit, estimated at about 1 meter over several years. This significant finding illustrates the potential for PBHs to affect celestial mechanics in ways previously not fully understood. Lead author Tung Tran from MIT conducted initial calculations indicating that a PBH could even displace a person by 6 meters if it were to pass nearby. To refine these predictions, the research team is collaborating with experts to simulate a broader range of solar system bodies, enhancing the accuracy of their models. Recent advancements in telemetry technology now enable astronomers to detect subtle orbital wobbles with high precision, allowing for the potential observation of these effects. Traditionally, dark matter was thought to interact solely through gravity, but this study suggests that it may be influenced by additional forces as well. The research particularly focuses on ultralight bosons, a hypothesized type of dark matter that interacts weakly with both matter and light, potentially forming detectable cloud-like structures. The team proposes using gravitational wave detectors, such as LIGO, to search for evidence of scalar field dark matter, considering its potential impacts on the LIGO interferometer itself. Published in the journal Physical Review D on September 17th, these findings contribute to the ongoing exploration of dark matter, which has been theorized since the 1930s and is believed to make up about a quarter of the universe's mass. Physicist Matt Kaplan highlighted the need for real data to confirm the presence of primordial black holes, underscoring the importance of the simulations conducted in this study. Regardless of whether evidence of PBHs is ultimately found, this research will enhance our understanding of dark matter and pave the way for future investigations. New research presented at the ECTR-IMS 2024 conference reveals significant findings regarding multiple sclerosis, or MS, treatment. The study indicates that initiating treatment with the anti-CD20 monoclonal antibody Ofatumumab can greatly reduce the risk of long-term disability accumulation in MS patients, particularly when compared to starting with immunomodulators like teriflunomide. The study tracked 1,184 participants, averaging 56 years of age, all of whom had not received MS medications in the previous 2 years. Notably, the benefits of Ofatumumab in reducing disability accumulation were sustained for up to 6 years, with no reported increase in adverse events. Dr. Sifat Sharman pointed out that early treatment with Ofatumumab can lower the risk of advancing to higher disability levels, showing reductions in progression rates by as much as 97% in cases of moderate disability. The research also focused on 282 patients with pediatric-onset MS, analyzing treatment effects based on the age at which they began therapy. Dr. Amit Bar-Or emphasized that delaying treatment with Ofatumumab does not compensate for the early control benefits observed in treatment-naive patients. For those on continuous Ofatumumab, the rates of confirmed disability worsening were 16.61%, compared to 23.74% for those receiving delayed treatment. However, the findings are not without caveats. A separate study published in Neurology found no difference in confirmed disability progression between anti-CD20 treated and untreated patients with primary progressive multiple sclerosis, or PPMS. Laure Michel, one of the study authors, stressed the importance of ongoing evaluation of MS therapies to ensure that their benefits outweigh risks, especially considering the high costs and potential side effects. The study advocates for early access to high-efficacy therapies for children with MS to improve long-term outcomes, as evidenced by a 0.57-point lower increase in EDSS scores in the early treatment group over a median follow-up of 10.8 years. It is also worth noting that several authors associated with the study have disclosed ties to the pharmaceutical industry, raising questions about potential conflicts of interest. A recent discovery has made waves in the field of chemistry, revealing the first experimental evidence of a stable single-electron covalent bond between two carbon atoms. Published on September 25, 2024 in the journal Nature, this finding confirms a theory proposed by Linus Pauling back in 1931, which speculated about the existence of such bonds. The research was spearheaded by Takuya Shimajiri and his team at the University of Tokyo, who have been at the forefront of exploring new realms in chemical bonding. To achieve this groundbreaking one-electron bond, the researchers oxidized a derivative of hexaphenylethane in the presence of iodine, resulting in dark violet crystals that exhibited stability. Unlike prior attempts that produced weak and unstable structures, this new molecule maintained sufficient stability for extensive analysis. X-ray diffraction analysis revealed that the carbon atoms in the crystals were positioned extremely close together, further confirming the presence of the single-electron covalent bond. While this discovery is a milestone for carbon chemistry, chemist Guy Bertrand from the University of California, Santa Barbara, remarked that its immediate applications remain uncertain. Nevertheless, Professor Yusuke Ishigaki noted that these findings could significantly enhance future research in chemical reactions and bonding theories. Shimajiri and his team are also delving into the fundamental nature of covalent bonds and the criteria that define them. This research opens new avenues in the chemistry of single-electron bonding. Given carbon's role as a primary building block of life and its importance in various industrial chemicals, the implications of this discovery could be profound, potentially leading to a deeper understanding of chemical reactions involving these unique bonds. A groundbreaking study from Australia has revealed critical insights into the relationship between light exposure, physical activity, and mood disorders. This extensive research involving nearly 87,000 participants is the largest of its kind and has been published in the journal Nature Mental Health. Mood disorders, which can affect up to 30% of individuals with major depressive disorder and bipolar disorder in a seasonal pattern, are recognized as the leading cause of disability worldwide. The study aims to unravel the complex interactions between sunlight, physical activity, and mood disorders using advanced digital tools. Findings indicate that increased light exposure at night is linked to a 30% higher risk of depression and other psychiatric disorders, including anxiety and PTSD. Alarmingly, many individuals spend about 90% of their day indoors under artificial lighting, which disrupts natural light and dark cycles that are crucial for mental health. Dr. Sean Kane, the lead author, emphasizes the need to adjust light exposure patterns to enhance well-being. He recommends maximizing bright light during the day while minimizing light exposure at night. Conversely, Exposure to bright light during the day has been found to serve as a protective measure for mental health and can reduce the risk of psychosis. The research also observed that individuals suffering from depression tend to have lower levels of physical activity, especially during periods of shorter daylight. Overall, optimizing light exposure emerges as a straightforward yet effective strategy to support mental health. Practical recommendations from the study include utilizing natural light during the day, taking afternoon walks outside, dimming lights in the evening, and reducing screen time at night. These findings hold true even after considering factors such as shift work and urban living. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. We'll be back Monday with everything you need to know.